Limiting reactant. Do you remember this? Okay. Do you remember what you have, what you need, all that stuff? Okay, so we're going to do that, but we're going to do it with gases. And so instead of me going through all the steps, you have all the steps before. Okay, they're in your notes. I'm going to go through and just give you an example. So here's an example. Let's say if a sample of N2 gas, occupies a volume of 100 milliliters, occupies a volume of 100 milliliters at a pressure of 21.8 atm, reacts with an H2 sample, reacts with an H2 sample that occupies a volume of, a volume of 500 milliliters, at a pressure of 14.7 atm, then what will the volume of NH3, then what will, long question, huh? Will the volume of NH3 at STPB if both reactants were originally at 298 K. Okay, lots of stuff, but again, remember characterizing gases is a little more complicated because you have to talk about volume, temperature, pressure, all that kind of stuff. So you can kind of picture it like this. Let's say I have 2 tanks of gas, okay? And what I'm doing is I'm taking those 2 tanks of gas and I've got pipes coming out of them and I have them coming together and I'm going to release those gases together and have them react. And they're going to react under normal temperatures and pressures. Okay? So they're going to come out, but when they react, they're going to come to the standard temperatures and pressures that we're used to. All right, so I'm going to come up here and make an equation here. So our equation is N2 plus 3H2 yields 2NH3. This is that same one we used before. So if I go up to the equation here, see, the stuff about N2, it tells me the volume of the N2, it tells me the pressure of the N2, and it tells me the temperature of the N2. Okay. So they tell me the volume is 100 milliliters for the N2, the pressure is 21.8, and the reactants were all at 298 K. So I'm going to put those in there. So this is this was volume equals 100 ml, but we don't need ml. We need liters when we're doing gas loss stuff a lot of times. So this is 0.001, and so volume equals 0.100 liters. So they gave me volume, they gave me pressure, 21.8 atm, and they gave me initial temperature as 298 K. So I have all my information about the N2. Now my stuff about the H2. I'm going to come up back up here. H2 sample occupies 500 milliliters. Pressure is 14.7 atm, and it's also at 298 K. Good. Come back up here. Okay, so this is going to be volume equals 500 ml, but we don't want ml, we want liter. 0.001 for 1 equals 0.500 liters. Pressure this time was 14.7 atm. Temperature again, 298 K. And then for this last one, the question is, what will the volume of NH3 be? Okay. And that's, I should do this too, at STP. So this one we're going to want to say, volume equals liters at STP. So again, most of the challenge of this problem is staying organized, knowing what thing goes with what thing. And then now you see you got a limiting reactant problem, because if you look at this, if I have V, P, and T, I have N. If I have V, P, and T, I have N. If I have two mole values, one of them is going to run out first. That's a limiting reactant. So let's solve that. So for I'm going to have for the N of N2 is going to be equal to PV over RT. So that's going to be pressure is 21.8 atm. Volume is 0.100 liters. R 0.08206 liter atmosphere over Kelvin mole times 298 K. If I do all that, I get 0.089 moles of N2. I'm going to do the same thing for H2. N of H2. You good? The pace good? I'm not going too fast? Okay. Right, so this is again going to be PV over RT. And so that this time it's going to be 14.7 ATM. And this time it's 500 milliliters or 0.5 liters. 0.500. 0.500 liters over the ideal gas constant 0.08206 liter atmosphere Kelvin mole times 298 K. I'm going to do that. I'm going to get 0.100 moles of H2. Now, if I were doing this on a sheet of paper, I would probably just string this all out. But doing it on the computer and I'm trying to project it, I'm probably going to just jump down a line right now. So that two things I just calculated: 0.089. I'm going to rewrite that down here. Now, if you've got room to work across, just keep working across like a limiting reactant problem. Moles of N2 and 0.100 moles of H2. This is what I label halves. You remember that again from before? So I've got my halves. I got to figure out now what I need by comparing these two to each other using coefficients, yeah? So the first one I'm going to get rid of moles of N2 and turn it into moles of H2. And the other one I'm going to get rid of moles of H2 and turn it into moles of N2. Just comparing them to each other. And from the balanced equation, that would be 3 H2s for every 1 N2. 1 and 1 to 3. So the reciprocal.
Did you get those numbers?
Yeah, from the coefficients. Oh, you know what? I made a mistake here too. Can I show you something? I copied this number wrong. I copied this one wrong right here. I just looked at the wrong spot. Everything else is right. It's just the number I put in there was wrong. I looked at the wrong part. That should be 0.301. Does everybody see that? This, I just changed this at the end of the H2 calculation. I read the wrong column off my notes. And so that would change it here when I copied it. So I apologize for that. 301. Are we all right with that?
Wait, why is it 3 to 1?
Because of the coefficients. So let's go up to our equation there.
Oh, I see.
1 n for every
I didn't
3
see
of
the
those.
3 in the original.
That's cool. Okay. And so when I do that calculation, I get 0.267 moles of H2. And I get here's the 0.100 that I copied before, moles of N2. And what do I label those as? Need. And if you recall, you're limited when you have less than you need, right? So where do I have less than I need? N2, yep. So right up here, this guy is my limit. So this is telling me you got 0.089 moles of N2. If you want to use all that N2 up, you need 0.267 moles of H2. Do I have at least 0.267 moles of H2? Yep, got plenty. But if I want to use up all this H2, 0.301, I need 0.1 moles of N2. Do I have 0.1 moles? Nope, ain't got enough.
May I use the bathroom?
Yes. Okay. All right, so now we're going to take our limit, 0.089 moles of N2, and get rid of moles of N2. Go to where we're headed, NH3. And the ratio there was, 1 to 2? 1 N2 for every 2 NH3s. 1 N2 for every 2 NH3s. And since we're at STP, we can cheat again and use that 22.4 liters per 1 mole. If we weren't at STP, then we'd have to solve for V equals nRT over P. Just that rearranged. And I get 3.99 liters NH3. Yes, sir.
So how come sometimes you write mole? Why don't you just keep the mole symbols at N throughout the whole thing? Does it change?
Well, look, right here it was N2. Okay. Is that what you're talking about? That
no,
N?
I'm talking about.
Okay.
I'm talking about like the fancy N that you use, like
The
labeling on
yeah,
top.
yeah.
How come, did you just use that throughout the entire problem, or do you want you have to write out moles? Like,
It is moles, yeah. It's like putting it like this, okay? Are you going to write, let's say, all the way through, let's say it's 10 liters. Are you going to write 10V?
Oh,
It's the same thing. It's the variable.
all right.
Yeah. Okay, so does that kind of bring back some memories about living reactor? Not too bad?
Yeah, what did you say about the last 22.4?
Okay, because we're at standard temperature and pressure right here, this is because we're at STP. Okay? Now, think about it like this. This is why that number works, okay? This comes from the fact, okay, this is just a little extra here. If I solve this for, actually, let me take that. PV equals nRT, just trust me that it can be arranged to V over N equals, let's see, P would come down, P would come down, P would be down here, and RT would be up here, right? So if I solve this, V over N is equal to 0.08206 liter atmosphere, Kelvin mole. Now if I'm at STP, this is going to be 273 K, and this is going to be 1 ATM, right? Because this is at STP, standard temperature and pressure. And if I take 0.08206 and I multiply that by 273, and then I divide that by 1, I get 22.4. And this would be then V over N equals 22.4. Well, volume is liters, N is moles. 22.4 liters per mole. So it just happens to work out at those conditions like that. Now, let's say we didn't have a STP, this N would be up over here, right? It'd be up on the top side, so that would be V equals nRT over P, and then you just have to solve
Also
it.
means that,
Yep.
What do you mean by that SPP?
Because you weren't here and you didn't get the notes. Standard temperature and pressure. 1 atmosphere, 273 Kelvin. Standard temperature and pressure. I would expect you not to understand. Good? Go over a little homework? Yep. Yep. Okay, so let's go over a little homework. All right.
What was the final answer?
3.99, that's right.
3.99 moles of ammonium. Or liters.
Mr. Markley,
Yo,
it's usually, you say it's usually gonna be liters of volume units,
um,
or mineral gases.
what I was saying is this. Whenever R is involved, you gotta be in liters, you gotta be in atmospheres, you gotta be in Kelvin, you gotta be in moles. If R is not involved, like say Boyle's law, just P and V, or Boyle's law, V and T, then volumes always have to match. So you can be liters or milliliters, whatever. Temperatures always have to be Kelvin, regardless. Pressures can match, as long as they match. Moles are moles, okay? So if you're unsure of should you be in the proper units or not, if you don't remember that, it just comes down to that, it's gotta be R, then you can always be in proper units, right? Or always be in those liters, moles, atmospheres. So if you do always go to liters, moles, atmospheres, it may cause you a little work, but then you are always assured that your units are gonna be okay. Does that kind of answer it?
Yeah.
Good. Okay, let's see, let me get a picture of a problem. Actually, I should have probably left that on. Let's see. Okay, let's try. Oh, hey, those of you guys that take prayer seriously and all that, if you'd say a prayer for me today, or for my wife today. Did I tell you what's going on with my wife? Yeah, yeah. I found out all it. I was like, I thought it was something complicated. It's tendonitis, is what it is. Okay, so it's tendonitis. And I was wrong about the cast, so it tells you how much I pay attention to my wife. No, I'm kidding. We just didn't discuss all the details of it, but she'll get a cast for 3 weeks, and then she's going to be off a week, go through physical therapy because they don't want her to get too weak, and then she's going to get cast for another 3 weeks. So she's going to have the cast for like 6 weeks, which is going to suck. But you know, I've been through it. I told her it's not that bad because I broke this hand in wrestling practice. I broke this bone about 3 years ago. Just going down to the mat, something stupid. And then I broke this wrist playing softball 2 years ago. And I was safe. I scored, and that was the second inning, and I finished the game. Just saying. I woke up the next day and it hurt really bad. Okay. All right, so let's go do something useful. Okay. Something useful for Bo. Bo Bauer. Yes. Go ahead. What? You gotta go. I trust you.
I gotta get an
Okay, that would be useful, volume 1. Let's do it this way. Bo, you get to pick the next one.
Andy Burns.
It wouldn't be a day without Andy. It wouldn't be a day. big one,
And
right?
then we can just solve, like, we can cancel out and stuff.
Yep. Okay, that's useful. It's got 0.5 holes. Okay, Andy, who you picking? It's your turn for revenge, and he goes for Malik. We'll say,
So Malik. Who is,
I don't even know what's going on. You don't even know what's going on.
so Malik. 8.
Good job. Well, you two. Who you picking?
Go Tyler. Tyler.
For this one, I've never paid so many money.
I paid $2 for it.
I
Yep.
Two, yeah.
Okay, good. Now who you picking?
Is that what you're getting?
Draw up a.
Is that your Alright, that's gross.
Get the M-Bucks.
I like it. I'm about to do that.
Mr. Park, it is so funny, last year Mr. Parsons not working out.
These are red marker.
Cut up one of my high cup. I see it's all on the hoodie, man. Go to the gym and pump out some reps.
He does.
I see it. That's so funny. Like, why wouldn't you just wear a cutoff? The purpose is not like trying to lose weight and wear it.
V1 over M.
Well, why don't we just write that first original equation? Yeah, go ahead. Like you said, you want to M.
Well, short dude with huge muscles. Mine's right here.
John, I paid you for a reason.
Smart. Is he huge? Yeah. Yeah. Like it's actually cut off though, like it's supposed to be.
Good. I take that. Who you want to pick now?
D.
I'm actually pretty pumped about it. Me too. I'm pumped for the game.
So that's the Q. I feel like this is like close.
I
Rally.
I miss.
Actually,
Everybody just to sit down and refresh.
I'm probably talking.
Yeah. Just like,
Exactly.
we get like 30 kids.
Remember when we were freshmen, we got like 40 kids here as freshmen. Freshman basketball games and we in there.
Okay.
How to get into it alone.
Okay, he wants to try and get N2 alone. Does anybody want to tell him a trick that I told you that if you got N2 or the thing you're looking for on the bottom? Tell him, Ethan.
Oh, you can flip it, right?
Start by just flipping the whole equation. Because think about it like this. Let's say you have this. Agree with that?
Yeah.
Agree with that? So the inverses are equal.
Okay.
So you could go ahead and multiply, but let me show you the pain in the butt way. So say you had this, V1 over N1 equals V2 over N2. Right? If I had that, one thing I could do is say, well, I'm going to multiply by N2 to get N2 out of the denominator. And then I got to come and I got to multiply this by N1 V1 to get these to go away. And I got this by N1 V1. And that's a mess, isn't it? Okay, so what we can do is just flip it, and then you only have one thing to move.
Wouldn't cross multiplication just work?
No, if you just flip it, then all you have to do is divide.
Yep,
Wait, why are we trying to get to?
we're trying to get to N2.
Gotcha. I got you. No, I got you.
Make sense? Nice way to treat your classmate.
This hood is tight, man. I don't know how.
And we are to, let's see, 1 minute. Okay, so you flipped it, good, that's good. All right, so now I'm gonna take each side, multiply by V2. Does that make sense?
We'll take a picture.
Gentlemen, listen up. Gentlemen. Gentlemen. Okay. Oh, this is N2, sorry. N2, so V2 we said was 20 liters. N1 we said was 0.5 moles. V2 we said was 11.2 liters. N2. So what is that? 10 divided by 11.2? So I get 0.89. Yeah,
What
0.89.
incarnation?
What period does lunch require?